The nice thing about magnetic fields is iron tends to align with the magnetic field lines. That's because in the presence of a magnetic field, iron becomes its own magnet as well. And so the north pole of the iron magnet wants to point to the south pole of the regular magnet. For example, I have here a handful of steel pennies and a neodymium magnet. If I stick them to the magnet, you can see that they just kind of hang off it like this. So each of these pennies on here has now become a magnet, and I can even stick more stuff to it. If you use a much bigger magnet, you can even hang weights off it like this. So each of these iron weights becomes its own magnet. So I have my giant magnet up here on this ladder, stick a 10-pound weight to it. Oh. Another 10-pound weight. Even this far away from it, it's still very magnetic. You can see I can still stick all these coins on it. In order to make the iron become its own magnet, the iron doesn't even have to be touching the magnet. For example, I have here my giant neodymium magnet above, and I can actually just stack the steel pennies up on my finger because they align to the magnetic field, so they stay pointing towards the magnetic field, but they're also magnetic themselves, so they stick to each other. Oh! You can see even more clearly that in the presence of a magnetic field, iron becomes its own magnet when you have a wider surface area for the magnet. And when I drop the steel pennies on here, you can see that they actually avoid each other. That's because the tips of each penny are the same pole, and so they want to repel each other slightly. But you can see that if I keep stacking these pennies up, eventually they'll get too tall and any instability will make them collapse down on each other. That means there's some sweet spot in the amount that they'll clump up and point upwards, and that they'll also fall back down. So they actually make spikes. That's the same reason why when you pour iron filings on a magnet, the iron filings pile up on each other in spike formations. And this is also the same reason why ferrofluid forms spikes as well. This cool characteristic of iron being ferromagnetic and following the magnetic field lines of a magnet becomes really useful if you want to visualize a magnetic field. I'm sure you've seen it done before with iron filings. If you put them on a paper and then pull a magnet underneath, you can see how it changes the iron filing layout according to how you move the magnet below it. So what I'm going to do is sandwich some ferrofluid in between two pieces of glass. What I'm using for my ferrofluid here is 1 part WD-40, 1 part ferrofluid. This just dilutes the ferrofluid a little bit and it's a little bit easier to view. Even though these pieces of glass are sandwiched together really tight, the ferrofluid particles in there are so small that they actually have plenty of room to spin around and move in there under the presence of a magnetic field. So once you have your pieces of glass sandwiched together, it doesn't look very nice, and when you bring a magnet to it, you can't really see anything happening. In order to see the ferrofluid moving around, we need to be able to see when they kind of chain together in there and form some lines. So what I have here is just a circle of LED lights. Now each of these LED lights is going to act as a source where we can see a glare coming off of it. So you can see the glare coming off of each of those LED lights. Well, the glare is only coming off in that direction because that's the way the particles are stacked right now. But I can change the alignment of the iron particles just by bringing a magnet near it. Now what's hard about this setup is you have to get a very thin layer of ferrofluid in between, and it's kind of hard to do. You have to use smaller pieces of glass and it makes it a little bit easier, but even then, if there's anything that gets on your glass, it'll make the gap not exactly right, so it won't be even throughout your whole glass. But a really easy way to do this is you don't even need 2 pieces of glass. All you need is 1 piece of glass and just wipe ferrofluid on one side. And then it makes it really visible because you get an extremely thin layer. Look how clear this is. What I love about just doing the one-sided glass is it makes it so you can control the layer extremely well. The only downside to this is the ferrofluid is slightly volatile, and so after a while it kind of dries up in the back and it doesn't look as good. But it's not that hard to correct it. You just put a few more drops on and smear it around and you can see it again right away. This magnetic paper has very tiny pieces of iron sandwiched between 2 layers, and you can see the pieces of iron when they align. So if I grab a magnet, it's really easy to see it behind it. Even if you put the magnet behind a box or something, it can go through it just fine. Because, as we know, in the presence of a magnetic field, iron becomes a magnet itself, I can find the iron nails in my wall if I just have another big magnet near it. So you can see right there, there's a nail. Hey everyone, thanks for watching another episode of the Action Lab. If you haven't subscribed yet, consider subscribing if you enjoyed this video. And also you can check out the Action Lab Shorts channel. It's my second channel where I do videos similar to this channel, but much shorter in a more summarized version in less than a minute. And thanks for watching, and I'll see you next time.